This is chapter 4, number 91. So the part A of the problem asks us, what is the takeoff speed of the locust if the locust jumps straight up in the air? The one thing it gives us is the height attained, which is 0.3 meters. We can determine other things, such as the final velocity, which is 0 meters per second, and the acceleration would just be negative g, which is negative 9.8. We could plug it into this equation right here and solve for vy of I, which would be the takeoff velocity or takeoff speed. So plug it in, here's a 0, negative 9.8 and 0.3 meters. Solve for vy of I and we get 2.42 meters per second, and that'll be its takeoff speed. And part B, it asks us the distance traveled, the takeoff speed of the locust if it's 40% higher than that of part A. And so we know that the distance traveled by the locust is 4 centimeters or 0.04 meters. Using these numbers, first we gotta solve for the 40%, which we just multiply that 0.4 and get 3.4. And just here's a conversion of centimeters and meters. We can use this. It should be A equals V over the distance, but yeah. So we got it's delta V. It's final velocity minus the initial velocity, and the distance right here. And we solve for acceleration, which would be 289 meters per second. Alright, so for part C, it asks us to compare the force of the legs it jumps with the locust's weight. So here's two equations: F equals ma, that would be the legs, and this would be its weight. So the mass equals, it gives us the mass, which is 2 grams or 0.002 kilograms. Solve for F, we get 0.578 newtons, and then here's its weight. Of course, would just be gravity rather than times its mass, 0.02. So if you compare these two numbers, 0.78 newtons compared to its legs, and the 0.02 newtons for its weight, we can determine that there's a small force acting on it due to gravity. Its weight, it's really small, 0.02 compared to the 0.578. Therefore, we can ignore its weight. So part C would be yes, we can ignore its weight.